Now once we're in manufacturer mode, we're going to select setups. And then we're going to right click on setups and create a new setup. This will bring up the standard box, the setup tab, and what we want to do is establish what is the model and what is the stock of our part. So we're going to go down and we're going to select model and go to the open up the model and open up the bodies, and we're going to select the body as the finished part as the model to reference for the setup itself. Then we go to stock, and we want to base the stock off the model body we made for it. So we're going to go from model and we're going to select on stock, and that will accept the stock as body as the stock. Now back to setup. This is where we are going to set up our origin for machining. Now for a lot of things, simple machining, 3-axis stuff, 1 or 2 vices, it's pretty common to set your origin at the top of the part. But when we get into more complicated fixturing schemes and 5-axis, I like to set it actually on the fixture itself that the stock is sitting on. So in this case, we're going to take the stock box point at the bottom of the dovetail. And the reason to do this is if you set your origin, say with the probe, on top of stock, and that stock is cut too thin, and you're going to run your program too low and you're going to run into your tooling. We also want to make sure that the z-axis is pointing the right direction, and although it is right now off model base, we're going to pick, if yours is not, we're going to pick the z-axis and y-axis method. And here I'm selecting the x-axis edge and selecting the top of the part to change the z-axis to be pointing in the direction of our neutral position of the part. We are now in the post-process tab, and we're going to put in a program number, which is going to be a variation of the part name. But it's you have a character limitation. You can't have more than 4 characters on a lot of different types of machines. In our program comment, we're going to put 73001-101, which is the name of the part, op2. We're calling this op2 because op1 would be preparing this to have the dovetail feature on it to hold it for the stock. You won't be doing that in class. It's going to be provided to you with the dovetail already on it, so we're not going to worry about that. And we're going to use work offset coordinate system 3, which is 56 on a Haas G56, and I believe we have that reserved for the rotary table. That way we don't have any interference from other classes, and we can still use the vise on G54 or 55. There's also, I want to make you aware, there's multiple offsets here that can be used. This is not real common in 5-axis, but very common in 3 and 4-axis milling, where you have multiple fixture locations, multiple offsets. It gives you the operation control to where you can move offset locations independently of each other when you have an array of parts. You may have a tolerance issue just in one location. It allows you to adjust that and duplicate the program code and just have a new offset called instead of having it programmed separately. So we're going to deselect that, but I wanted to make you aware it was there. Okay, and then we're going to hit OK, and program in this mode. You have your part, you orientate it to the machine, and then we're going to be working close up with the part itself. All right, that's it for setting up your part in Fusion 360 for full 5-axis. Okay, now we're going to get into programming this part. All right, let's take a look at it. We're looking at it as if we're staring at the machine, looking at the rotary table, which would be on the right, with the Raptor vise holding onto the piece from below. The first thing we're going to do is a 2D facing, and you're going to select a tool from our tool library, and you need to download this tool library. It's Sierra VF1 aluminum. We're using the same tool library. Some of the tools are going to be slightly longer in the VF2, so we need to make sure they're long enough that we don't have collision detection issues. So we're going to use tool number 1. You should be familiar with it at this point. It's a Kennametal face mill. And we're going to select that tool. And the default RPMs and feeds and speeds seem a little off to me. So we're going to reset those. Set the RPM to 7,000. RPM. (280 inches a minute). That's pretty fast with this shell mill. It's designed to go fast. We're going to set all of these feed rates to the same. Mostly the shell mill, if it's starting off the workpiece, there really isn't a ramp or a feed rate. It's a sideways move and off the workpiece. So we're just going to go ahead with 280 on all those. Looks like I made a mistake. It should be 280 up there. And it looks like I accidentally punched in my RPM at surface footage. So we're going to go back up and fix that, 7,000 RPM. Okay. And let the surface speed do what it's going to do. All right, we're going to move on to the geometry tab, and we're going to basically mill off the top of this. But since we're working on 5-axis, we need to set our tool orientation. Now, right now, the way the model orientation is actually okay, but I'm in the habit of, once we start doing multi-axis stuff, you're going to select your Z-axis that needs to be perpendicular to the primary spindle when it's in the neutral position. So this part sits on a C-axis and an A-axis, and the C is in orientation with the primary spindle. We pick that plane of the top face, and then X is going to be an edge. It's horizontal. That's pointing to the right, and that's our other rotating axis. Is what's rotates about X is the A-axis. Okay, now you don't have to necessarily select the contours, but you can. It's going to be the top of the part. Now we're going to move on to heights. And they've changed how Fusion handles all this. It's just the way that's selected. So you got the highest selected of either stock top, model top, fixture top, and it has 200 thousandths onto it. Then we have our feed height that's based off the top height. So we're going to leave the 200 thousandths offset on default. Some shops that's a lot in the feed height, but we're doing 5-axis, so we want you to have reaction time. And it's okay for the top height right now to be based off stock top, because we're removing the material from the top of the stock. We have a whole bunch of different options. And the bottom height, we want it to be based off model top. We want to cut right to the top of the model, and we're only skimming 30 thousandths off the very top of this. And that's the difference between the light blue and the dark blue lines, is how much we're going to be removing with this operation. Okay, we're going to go to passes. And for the most part, I leave this at default. The pass extension number has to be slightly larger than the diameter, half the diameter of the cutter. It allows it to pass beyond the part and have full cleanup. So we're just going to leave 1.5 inches fine. Our step over is 2 inches and it looks like 56,006 That actually can be bigger, can be up to 80% engagement of the diameter of the cutter, or in some cases full. So let's look at what 80% would be if we had to do multiple passes. Looks like 80% of 3 inches is 2.4 inches. So you could go a little bit more aggressive on that. But again, on this one, I'm just going to be cutting one face. One pass probably right down the middle. Okay, so we're going to go to the linking tab, and we're going to pretty much leave all this at default. The one thing I don't do is vertical lead ins. It's not very good on the inserts. They don't all plunge that way. So we're going to set that at 0. for vertical lead-ins. Then we have our other boxes, lead in and lead out, and we have our, we want those the same. And then the transition type is smooth. On the older machines, I had to do a rectangular move, but with the curvature there, it moves smoother and more efficiently. All right, so now we're going to come down and over to the right and feed to the left and pick up. I'm not so sure I like that because we have this big rotary table over to the right. So let's take a look at where this occurs with the machine in play. And if we look at the machine right now, we have it plunging at the right and going to the left. I think I'm going to avoid that. We're going to change that. We're going to think about this a little bit more. We want the cutter to go the opposite direction so that we're not risking hitting the fixture. There may be enough clearance, but why push it when we have plenty of room on another axis? So we want this passed around instead of in x-axis, in the y-axis of the machine. To do this, we're going to go back into the routine. Okay, so we're going to right click on our routine and we're going to go edit. Sorry, we're going to the passes tab. And where it says pass direction, we're going to go from 0, we're going to change that to 90. And that'll force our tool path to go the opposite direction. Then we're going to select OK, and you can see the result. It's going to start towards us and pull apart towards us or have the cutter go away. That way we can see from the operator standpoint how close it is when it first starts feeding into the workpiece. And we're going to be way away from any collision on our 5th axis. So now we're going to select on simulate without the machine and see what our face mill does. Okay, so it comes across our part and does a pretty good cut. Sometimes the holder gets in the way, so if you don't want to see the holder, you can always go to shaft or holder or flute, and you can have different options of your display there. So there's the same cutter with the holder suppressed. Okay, so now we're going to cut the next routine is to cut this pocket at the top. So we're going to go to 2D pocket, and we're going to select a different tool. We're going to select from our Zero VF1 aluminum library. We're going to select the 1/2 inch flat end mill. Okay, we're going to adjust some things here. 4,000, 40 inches a minute all across the board. This is I typically go 20 on ramp and plunge rates for this type of cutter, doing this type of work. Okay, we're going to then select what we're going to cut, which is the circle. And we need to set the tool orientation. And we can select the bottom of the floor there. And now selecting the orientation of the spindle and x-axis. Go to the next tab, we're going to the heights tab. A lot of times I change this to model top at this point because we've already milled down the top. Now we're going to probably switch back to stock top for some other things. Okay, we're going to go to passes. Under passes, we're always going to do sideways left compensation. That's correct. And we're going to keep these other things at default. And then our maximum step over, we're going to, again, you can do up to 80% of the cutter. So if we took a 1/2 inch cutter and multiply that by 0.8, so 0.5 times 0.8, you get 400 thousandths. So we could be more aggressive with this. This is a small feature though, so we don't want to take off too much at once and have a bad finish. Okay, on the depths, we're going to select multiple depths. We're going to put in a 1/2 inch for our step downs and 1 finishing step down. And that finishing step down will be set at 0.08, it's fine. And then we want to do finish passes on the sides. We want to make sure the compensation is set for wear so that the operator can adjust the cutter as it wears. We're going to do 1 finishing pass, and that step over is set at 50 thousandths right now. But we are going to finish all at final depth. That way we get a full side of the end mill, clean it up with a pocket. If you have enough flute length, that's the better finish way to do it. Okay, we're going to go down stock to leaf smoothing. We're going to turn that on because it is a circle. It calculates the points closer together. And we're moving on to the 3-axis tab. Nothing to change here. And then we're going to select on the linking tab. Now we're in the linking tab. We leave a lot of this at default. We're going to skip down. One thing we are going to take out is this vertical lead-in radius. And we have a lead-in and lead-out are going to be the same size. For aluminum and a part like this, I don't do elaborate ramps. It just takes too long. We're going to do a plunge. And that's why we set our feed rate so low for plunging. There we go. We've got our cut. All right, looks good.